Good morning and welcome to today's AI2GO session on sustainable AI for sustainable businesses. My name is Ulrike Daniels, and on behalf of NRW and Piemonte Innova, I would like to welcome you to today's session, 1 hour dedicated to artificial intelligence and its potential for sustainable businesses. Piemonte Innova and us, we have organized this webinar also to strengthen the cooperation between the two regions, Piedmont and NRW, and I hope you will all enjoy the exchange. Before we start with the program, I would like to use the opportunity to thank all our partners that have supported us in the promotion of this initiative, the Enterprise Europe Network, the Lamar Institute for Machine Learning and Artificial Intelligence, NRW Innovative, the Italian Technology Cluster for Smart Communities, and the European projects Restart SMEs and AI-BC Euro clusters. Special thanks go to Silvana Sanfeliu, with whom I have organized this session, and she will join us today, not from Piedmont actually, but from Lithuania, and I would like to welcome her now for a short greeting.
Okay, thank you, Ulrike. Good morning, everyone. I'm Silvana Sanfeliu. I'm working on Fondazione Piemonte Innova, based in Turin, Italy, and we're actually coordinating an ICT cluster and a smart communities cluster, working around at the Italian level on technologies and this application. So we're really eager to organize this event together with Ulrike and with other co-workers, and is like let's hope it's the first, let's say, event of our collaboration together. So thank you very much.
Thank you, Silvana. We will now start with an inspiring talk to whet your appetite for implementing AI in your own businesses. For that, I would like to welcome our Managing Director, Christian Thiemat. Before he starts, I would like to just point out that we are on a quite tight schedule today, but if you have questions, just feel free to put them in the Q&A section. And if we have a few minutes left, the speakers will be happy to answer them, and otherwise they will just answer them in written form through the chat.
Yeah, thank you very much, Ulrike. Thank you, Silvana. It's my pleasure being here today, and I think this is also quite an amazing topic that we're talking about, and I'm very happy that we also have some quite inspiring speakers after me to really dive into the real applications of AI and sustainability. So I think it's going to be a quite interesting talk today, and so let's get started. And what I would like to do is a bit discussing about the question of, okay, what's the journey of AI? What have we seen there? What are the developments? Then also, what are the opportunities that AI can bring us, especially with the focus on sustainability? And then also, we're very briefly looking into, okay, how can we now actually start smartly applying AI? And having said this, I would like to start with a first and brief introduction definition of artificial intelligence. And that is based off the Professor John McCarthy, who basically organized the Dartmouth workshop back in the 50s. And he defined the name artificial intelligence as we use it as for today. And he basically said, okay, artificial intelligence is the science and engineering of making intelligent machines. So we basically, as humans, make machines somehow intelligent for a specific task. And that specific task could be helping us in terms of sustainability. Now, a lot of people, and including myself, struggle with the real definition of AI. So how do we perceive it? What is really artificial intelligence? And that's because we see that artificial intelligence is actually a moving target. So when we look in some major of those components during the development is, when I was growing up, I was playing chess. And for me, it was one of those big news when Deep Blue actually won against Garry Kasparov, the chess champion, in 1997. That's like more than 20 years ago. And then we had a long period of silence. And then basically, IBM Watson was able to win Jeopardy against the best Jeopardy players. For all who don't know Jeopardy, Jeopardy is basically asking world knowledge questions, and they basically give you an answer, and you need to phrase the question. So that combines knowledge of the world and combining somehow language capabilities, which was very hard to program back in these days. And then the development gets faster and faster and faster. Now, AlphaGo, the strategic game that the Chinese, Japanese, Korean people play, like the people in Asia, way more combinations were possible than in chess, and was somehow thought to be not beatable with computer science. Was beaten 2016. The world best Go player was beaten by AlphaGo. And one of the, I think, astonishing things was 2017-18 when AlphaGo 0 basically just got the rules of Go and trained itself to how to play Go. And it basically won against AlphaGo, the original version, 100-0. And that was based on developing an own strategy, how to solve this game, how to play this game. And that was where people were thinking, okay, there's quite some capabilities in certain specific areas. So what else can AI do? Now, then I think the latest news, everybody got used to it, GPT-3, but nowadays also ChatGPT. So an AI where you can actually talk with, where you can interact, where it gives you like eloquent text. So that is basically what's now happening these days. And the question is, how will all this thing end? But I think what is very clear is, AI is here to stay. And AI is here to stay in the sense that we will for sure need to understand that speech recognition, pattern recognition, image recognition, all the things, generating text is all things that will be there. And I think it's also very important that it can help us to actually tackle our problems. We here in Germany, and I think it's somehow similar also with Italy and all over Europe, we also see facing a lot of transformation pressure from bringing our economies to somehow climate neutral substance. And that is where a lot of people have a lot of doubts and questions how to solve this. And there's also this whole question of digitization. And we truly believe that AI can help both with the digitization roadmap, but also bringing sustainability back into the industry and the corporations. And I will just give you some examples, where can actually AI is there to help. One of those examples is, for example, with the incineration plant where you burn trash. Up until now, not every trash gets recycled. So whatever you have, at some point in time, you need to burn it because digging it at some point to the earth is also not so viable. So when you do this, a lot of things is how can you steer this process efficiently so that you get the most out of the trash and get the most or the least emissions CO2 and CO. And here a neural network came into play. That's a real example from North Rhine-Westphalia, where people were looking into how do people actually steer this and how do they steer this? There's the amount of trash coming from, let's say, here up there, and then it falls into some big oven where it's burned. And then you have some flaps where you regulate the air supply of the burning process. And this is basically done like 50% on one flap and 70% on the other flap, and it's regulated every hour when people are looking at the numbers and say, okay, it's too hot or it's too cold. And with this neural network, actually, they are coming into a situation where they steer this like 53% now and 77% for this other flap, and they can actually steer it on a minute base. And they're reducing the CO2 emissions by like 10–15%. They're actually getting more energy out of it. And thinking about times where we want to save gasoline, we want to save gas, we want to save all of these energy resources, I think that's good news to really use AI and neural networks to solve this in a better way. Another example, and is actually combining a bit the whole question of sustainable water supplies, but also the question of energy efficiency is how to actually steer the pumping processes of refilling tanks, etc. A very simple and pragmatic guess was to say, okay, let's just do it overnight, because then we will basically use night electricity. The situation in real life is a bit more complicated. Not every of the tanks can be refilled during overnight pumping actions. And also the electricity is somehow more available during daytimes, especially with the renewable energies and solar energy. So they were now implementing a forecasting and a decision supporting mechanism to actually steer this pumping process based on the demand and supply of water, but also where the electricity is actually available. Now, and that also saves them money, but it also saves electricity and helps to actually have a better and more sustainable water supply. And talking about the big issues and topics of sustainability, food. Yeah, food is one of those items. Yeah, especially in my Italian cuisine, to be honest, yeah, because I really love it. Yeah, I'm not a big fan of the German cuisine, but what we see, especially in Germany, I see is a lot of waste of food. Yeah, so a lot of stuff gets produced and it never gets sold, and what not gets sold gets more or less thrown away. And here, one of the startup from Germany, from Cologne, is applying a solution where they say, okay, we use different input data to actually forecast how much demand for a certain food or product are actually given there, for example, for bakeries. And then they basically help them to optimize their production numbers so that what they produce gets actually sold and not thrown away. And that saves, I think in some of those example cases, 20–30% of stuff that gets just thrown away. And I think these are items where I truly believe that AI can help us to have a more sustainable look at life and how we actually deal with our food supply and other things. And maybe one last example is the traffic. So obviously everybody would love to have everyone just using trains, putting all the transportation on trains. Reality is we still have a lot of stuff just being transported by trucks, etc. And there is a lot of gasoline that's used for this. And so the question is, can we basically take weather data, traffic data, also be playing around with flexible delivery windows so that we actually can optimize the whole delivery process. And that's what another company, AI2GO, is doing and helping to reduce the CO2 emissions, because the transportation gets less and the transportation duration gets less and kilometers driven gets less. So that's also how people can actually save money. That's helping them to finance their transformation, but also it helps our environment because it just gets less CO2 emissions. Now, there's just some examples, and we will see some more during the remainder of this talk and this session. So just briefly, so if you would like to start smartly, that's how we call it, I could give tons of ideas and thoughts what is really helpful for looking into starting an AI journey to applying AI. But two things I would like to really highlight here are expectation management. So AI, although the current news are saying whatever can AI do is so impressive, it will solve every problems. Applying AI in a corporate context is about it solves a certain problem with a certain algorithm, with a certain technique. So manage the expectations, use pragmatic use case, make it measurable so that you can say, with applying this neural network for my incineration plant, I save energy or I have reduced emissions. And the other thing is, it all is a team sport. So if you would like to apply AI, it is very important to get all stakeholders, all the customers, but also the thinking of the processes, etc., involved, so that you actually know how will this interplay with the whole ecosystem that you're applying it into. So if you would really like to start an AI journey, just make sure that you get everybody on board, and make sure that those people who know the domain are actually taken into consideration. And having said this, we from KI NRW have a broad portfolio to actually help to understand what AI can do. And we have certain things like the AI walls, different formats like AI2GO as of today, but also certain amounts of workshop formats for customers, for corporates, like AI design sprints, AI shadows, and AI kickoffs, where we really want to help you start your AI journey. So if whoever's interested, whoever wants to start the AI journey now, can actually directly contact me. And here I would have my LinkedIn profile. So if you would like just to scan my QR code and if you want to connect, just do so. Other than that, I'm very much looking forward to the other talks, and thank you very much for your time. And hope you have a great session today.
Thank you very much, Christian. I don't see any questions in the chat, but I think if questions come up throughout the rest of the session, please feel free to put them in the Q&A, and Christian will be here to answer them. I hope you all now have a better picture of how to get started with AI and why you should. But while AI has tremendous potential for more sustainable businesses, it is also, or it can be, very energy intensive. This is why we have invited Sebastian Buschjäger today from the Lamar Institute and Dortmund University, who will introduce us to methods how to make machine learning algorithms more resource efficient. Welcome, Sebastian.
Yeah, thank you for the kind introduction. Let's start the screen share. So I hope this works. If not, then somebody needs to scream now. Okay, yeah, I don't hear anybody scream, so I assume
It's
this
working.
works. Perfect, thank you. Yeah, thank you for the kind introduction. My name is Sebastian Buschjäger. I'm a postdoctoral researcher at the Lamar Institute for Machine Learning and Artificial Intelligence. And I'm the coordinator for resource-aware machine learning there. And we just heard that AI is here to stay. And so at some point, in order to be sustainable, we need to think about the energy consumption of AI itself. And this is usually something we overlook a bit. We know that training a model takes a lot of time and effort, and hence also a lot of energy usually. But what really takes the cake in the end is usually applying the model. And for that, I have a small example. So at some point in the near future, hopefully we have the autopilot feature in all our cars. So we don't need to think about driving from A to B, but the car does it itself. At least we have some prototypes now on the road. And for example, Tesla is pretty outspoken about how they do it. They use a deep learning model for image recognition and steering. So basically, they have a camera setup that takes let's say 30 frames per second, and each frame gets analyzed, and then the car decides if it needs to accelerate, brake, drive to the left, to the right, and so on and so forth. And maybe you heard about that, or maybe you know that by first-hand experience. Deep learning is very resource intense. And of course, the guys from Tesla, they are smart engineers. They also know that. They say, okay, we have this technology, it works well, but it requires a lot of energy. So let's build our custom inferencing chip. And they came up with their own chip that requires roughly 60 watts and does nothing else but just run this machine learning model over and over and over again to keep up with the 30 frames from the camera. Now, if you have such a system, you can think about what would happen if we deploy this kind of device in all our cars. And ultimately, that's the goal, right? We want to have self-driving cars all the way. So for all the trips we take, we don't need to think about it, but the car just drives itself. This can have a huge impact on the environment. And I tried to find some numbers, how bad that really is. And so in Germany, we have this weird thing that we like cars, and at the same time, we also like statistics. And the so-called Kraftfahrtbundesamt has an estimate in how much we travel per year. And so pre-pandemic in 2018, all the cars in Germany combined traveled roughly a distance of 630 billion kilometers. And so my idea is, or my question is, what would happen if we use the autopilot feature from Tesla in all those trips? And how much energy does that cost? And in order to get roughly the time we spend in our cars, we can take the average speed of a personal car in Germany, combine that with the 630 billion kilometers, combine that with the energy consumption, and then we get the total amount of energy we use for all those trips. And this is actually a fun little guessing game you can do. So what would be the average speed of a personal car in Germany? On the one hand, we have the Autobahn, so at some place you can drive as fast as you want. But then on the other hand, of course, most trips are in inner cities, and there the speed limit is 50 kilometers an hour. And I did that with a couple of my colleagues, and we came up with very different numbers. And so as it turns out, I found this study that estimates that the average speed of a personal car is around 45 kilometers per hour, which I guess makes sense because there are traffic lights and most trips are in inner cities. So it kind of makes sense. Now, combining all those numbers, we get a total energy consumption of around 0.8 terawatt hours. And to me, as a computer scientist, I'm more used to dealing in watts or milliwatts or something. So I have no idea what terawatt actually means. So I tried to find something that gives me a reference. And turns out that the largest run-of-the-river hydroelectricity plant we have in Germany also produces roughly 0.8 terawatt hours of electricity per year. And so put differently, if we want to deploy machine learning in all the cars and use that for all the trips, we would need to build an entire electricity plant just to power this one feature. And I think this is a good example why we need to think about the energy consumption of machine learning itself, especially after the training phase, when we deploy it across a lot of different users and devices. So to tackle that a bit more, this is what the usual machine learning pipeline would look like. We start with our business problem, we analyze it, and at some point we say, okay, we need machine learning. This can really help us here. And then we go over into this modeling phase where we gather data, we do some processing with the data, interact with the data, try to get an idea of what we can do with the data, and then at some point train models over and over again until we find one model that really fits our needs. And this entire process is usually done on a large server, or at least on a desktop PC in the company, or let's say over AWS or something like that. And once we have done that, we take this model and deploy it. And in our example from before, the small, quote unquote, small device here would be a car, which then executes the model over and over and over again to perform some predictions for the end user to make this model really useful. So what you can see here is whatever we do in the later part of the stages of this pipeline determines what we can do in the beginning. So if we have a very, very small resource constraint device that, let's say, only can store a couple of megabytes of data, then we cannot train a huge neural network on the server. I mean, we could do that, but there is no chance that we can deploy it. So whatever we have available in the later stages of this pipeline determines what we can do in the beginning. So we should only train those models that we can actually use in the end. And so that means that we need to consider the deployment of the models already during the initial phases of the design of our system. And so what I would propose is to use this updated machine learning pipeline where we have the business problem and we analyze, okay, machine learning, this is useful and we should use machine learning to get some benefit. But at the same time, we think about how can we deploy that in the end and how much energy does that cost? What kind of device should we use here? Because in this scenario, the small device gives the constraints derived from the business problem. So when we know we want to have a self-driving car, it's immediately clear we have limited resources compared to what we can do on a large server. And this is now kind of obvious. The model should always be as small as possible, but as big as necessary. So when the business problem tells us we need to have at least 90% accuracy in order to make it useful, then we need to find a model that has at least 90% accuracy, and there's no way around that. And if we need to increase the model over and over again until we reach that point, then this is just how the business problem looks like. But if we have the choice or the opportunity to choose between two different models, and one is a very big neural network with millions of parameters, and the other one is a simple linear regression model, then and both have roughly the same performance, then it's probably better to take the smaller model because that is smaller memory, that usually means smaller in compute, and then ultimately smaller in energy consumption, and this is what we're after. So again, this is kind of obvious, but we should always start with the smaller models and then gradually work towards the bigger ones. So to wrap this idea up, one idea is to use decision trees, and I hope you kind of know what decision trees are. If not, they are what the name says. We make very simple decisions in each of the nodes of a tree, and then at some point we get to a prediction. Random forest is when you have multiple decision trees, and usually random forests work pretty well. They are somewhat small, quote unquote, and have a decent accuracy. And so one idea is to start with a decision tree over the random forest and then see what how good the accuracy is, and then increase gradually from that. And this now gets into the part of the research we are doing at the Lamar Institute. Even a random forest can already challenge small resource constraint devices. So just to show you here, I trained a random forest on 6 different data sets. And as you can see, the accuracy looks decent enough. It's above 90% in most cases. That seems to be okay. But at the same time, the model size is 25 megabytes, 32 megabytes, 25 megabytes, and so on. And if we have a very small resource constrained device, let's say something in an IoT context, then we usually cannot store that much data, let alone execute it. And so for us, one of the research questions we have is, can we compute a small and an accurate tree ensemble? And then we can look at the literature, and there are basically 2 different ideas. The first one is, given this large forest we have, and we like that, it has a good accuracy, maybe it's enough to select only a few trees. So to put it in a picture, we have our big forest, do some computation, and then come up with a small forest that hopefully works quite well. The other idea is to start from the other part of the end, the other part of the spectrum. Start with a small forest and try to improve its accuracy. So again, to put that in the picture, we have our small forest, do some processing, and then hopefully we have the better one. And having those 2 ideas, we have to make a choice, which one is the better choice. So which method works better? And so one observation you can have here is, if you have a big random forest, then that means you already have a small random forest inside of this big one. And so this is one idea we recently published in order to combine those 2 ideas. Can we extract a small forest from the big one and refine it at the same time? So again, to put that into a picture, can we extract a small forest out of this big one, refine it, and then have a nice, well-rounded random forest? Of course, this is research, so we have to put that into some mathematics in order to publish that. But I don't really want to go into details here. If you're interested in that, you can ask me questions, of course, or have a look at the paper. What I really want to show you here is the results in the end. Again, we have our 6 data sets with different accuracies and different model sizes. And then we have our new method applied to the same data sets. And as you can see, in all cases, the accuracy is at least as good as before. In some cases, it's even much better. At the same time, the memory consumption is vastly reduced. So we're going down from 25 megabytes to only a couple of kilobytes. And that effectively means is, when we think back about the deployment of our model, we can get away with a very, very tiny device that only uses a fraction of the energy of what we would require to execute a model this big. And this is ultimately what we're after, to have a small model and then have a very, very small resource constrained device that can still execute this small model. In order to have that, we need to have both. We need to think about the deployment and the model at the same time. Yeah, this is kind of the main takeaway I want you to take away from this. Machine learning on small devices matter, especially when we have this kind of vertical deployment of machine learning models across different users and different devices. Another go-to example are smartphones. Smartphones are getting bigger and bigger with each generation, but at the same time, we implement way more machine learning models nowadays into these devices. So this can quickly add up to a lot of energy we require to run all these models. And so what I would do, especially in a corporate context, I would always try to go for a kind of a backwards design. So during the initial stages of thinking about using machine learning, take the time and think about how can we run that in the end? How can we deploy that in the end? Is this a service that needs to run once every few minutes? Then it's probably fine. Is it a service that needs to run every few seconds in a car? Then we should probably think about what kind of hardware will this model run on. Yeah, and then last, we talked a bit about what's called ensemble pruning and leaf refinement. So ensemble pruning is when you have a large forest and you take out a few trees. And this is just more kind of a look at what you can do here. There are lots of different other papers for other methods. Feel free to check out the paper or ask me any questions. Yeah, thank you very much.
Thank you very much, Sebastian, for that important input. I think the reduction was really impressive. Next up, we will come to a company that is already applying AI to meet different challenges in ESG management. And for that, I would like to welcome Edmondo Claudini. He is Corporate Organization and Quality Manager at Selectra. Welcome, Edmondo.
Good morning to everyone. I try to show you our organization before analyze the AI support. Selectra was founded in 1974, Italian company that produce wiring harnesses for the different products. Now we are the European partner for home appliance, and we need to are flexible to invest in the new technologies and to perform advanced quality and to take under control our cost and our quality process. You can see our main customer, for example, Whirlpool Electrolux or Harrison Thermo for the water heaters, or Enel for the cabinet switch. I think that is very likely that some our product is now present in your house or in your company, because we produce a lot of product for different kind of the home appliance or other products. This is our business milestone. I underline that in the 2021 years, Electrolux gave us the Supplier Award for the best supply of the world during the COVID emergency. This is our European organization. We are more or less 550 people in the Europe, and we are in Italy, Romania, Ukraine, and Serbia.
And Montes, just one
Yes.
thing, are you passing the presentation already or not? Because we're just seeing the first slide.
The first slide, this
Yeah,
one.
we're only seeing the first one, so just for you to know if you're passing by or just seeing the first slide.
Ok.
Eri fermo in quella, quindi se vuoi passare era solo quella.
Ok. Our program for the investing in the future is for the internal process digitalization and automatization, competence and skill for the people, new facilities and space, development certification. For example, we are the certification in progress for all our sites in Europe, and we plan to certify the Italian and the Romanian sites within this year for the safety, social standard, energy, and environment point for this year, within this year. Selectra is a CDP disclosure from 2020, is a big program, European program to analyze our footprint, CO2 footprint for the climate change, for the forest and the water consumption. And we need to take under control our system organization for the logistic and energy and the material, and we need to manage a lot of data, and we plan a big target for the next year. For example, in the logistic organization, we plan to reduce of the 15% our CO2 emission in 3 years. And we need to improve our solar energy production. For example, we think that in the next 2 years, we provide to produce the 100% of energy for our production in Italy and also in Romania. But we need understand that we are a much problem to organize our company, because Selectra is there are some problem with the share. You see my slide now?
Yes, we're seeing it.
Okay. How can the AI help Selectra to achieve the objective? Our main challenge is we need to analyze a lot of data to determine our CO2 footprint for each our product as requested by our customer. We need to involve our global suppliers with different cultures, languages, sensibilities, and law for the ESG topic. We need to involve also our employees with different cultures, languages, sensibility, and law. And we need to know in real time the deviation that we can meet in our organization to be very quick to intercept and analyze them. We need a custom-made tool around our needs. There are a lot of AI software and app solution, for example, to manage the supply chain, but they are much expensive and we need to impose them at our suppliers. In this moment, we are more of 200 international suppliers. In my opinion, this is very impossible to involve our supplier. Selectra solution. Our internal IT and our external software house have developed a novel software that connect our system in the group and is connected with SAP, MRP, and other platform connected with our customer and suppliers. The new project consists in an app connector with our IT network and IT and the AI to elaborate the data following our company policies. The output are platform to permit the data ESG only, interchange between Selectra, customer, and our supplier. Internal platform to manage the training and the information needs for all people of the group. Internal platform that send automatic alert after the elaboration group data to prevent the deviation in production and in our organization. This is a big project, but in this moment we are also the huge helps for this kind of the project. Real progress, in our opinion, is the encounter of the true experience in the horizon of futures. Thank you for attention.
Thank you very much for sharing your experiences with AI. If you have questions, please feel free to put them in the chat. I would now like to introduce you to two startup solutions, one from Piedmont and one from NRW. And starting with NRW, I would like to welcome Mark Röminger, who is a senior account executive at Double AI. Welcome.
Perfect. Thank you for the introduction. And firstly, thanks for being given the chance to participate in this very highly interesting event. My name is, as just mentioned, Mark Röminger. I'm responsible here as Senior Account Manager at Double, and my goal is to spread our solution across the globe. I will now share my screen. Right, and I will present you today how artificial intelligence is able to make energy operation in buildings more sustainable, whereas our overarching goal is to decarbonize millions of commercial square meters in the most scalable, cost-effective, and sustainable way. Let's have a quick look on the agenda. So the first part will cover who we are, why we are doing what we do. The second part depicts the software solution. So how does it actually work? And in the end, I will share which requirements need to fulfill to be able to achieve such savings for our customers. So who are we? We are a software company that helps commercial property owners and operators in reducing HVAC energy consumption by up to 30% instantly with an AI-based control without no investment. A few facts and figures about us. We were founded in 2018. We are currently managing more than 1.6 million of square meters. On average, overall asset types, we generate around 26% in energy savings, which in the end results in roughly €5 per square meter per year. And as we see a huge or an increasing request and inquiries from whole Europe, we are really expanding rapidly. Amongst our clients are big building operators and owners, but we also focus on investment, real estate companies and asset management companies, because obviously we see there a huge lever. Next to that, we collaborate with integrators such as E.ON or also Delta Controls, and our software is certified and vetted by international standard, the Wired Score. So why do we actually focus on the HVAC systems? Well, I mean, in the meantime, I guess that almost everybody knows that the building sector is responsible for a huge amount of world's annual CO2 emissions. And if we now deep dive a bit more into the building sectors and focus on the commercial sector part, we see that the HVAC HVAC, heating, ventilation, and air conditioning systems consume the biggest amount of the energy consumption. Hence, there's really a huge lever and impact when we are really able to optimize this complete energy consumption. So this is actually a recommendation how we would set up a roadmap to net zero. But actually, we see that the reality completely differs. Meaning, in our talks, in our daily talks with our clients and also with prospects, we see that the agenda is packed with initiatives that focus rather on the high invest and time-consuming activities, such as refurbishment, such as installations of new technical devices, right? But in our point of view, they kind of neglect and really forget that they can really do, they really can have an impact right away by focusing really on optimization. And this is actually what we're doing, right? So we want to also re-challenge the big corporations and really reshuffle also the agenda by starting with optimization. That also means that you really get in the first step data transparency, which is always a huge lack when we talk with big companies about energy consumption, right? So this is really kind of a blind spot. And once they have this transparency of data, then subsequently they can really make strategic decisions based on data. So I just mentioned it. What is it that we actually do? So we want to operate the existing HVAC systems more efficiently. And how are we doing it? Via usage of a cloud-based application that sits on top of the building management system. And there it's on the one side, it reads data from sensors and actuators in real time. So all the data points that are connected to the building management system, but it also incorporates and combines it with outdoor variables and aggregates the data via artificial intelligence. So in the end, pretty simply, really simply explained, our solution really predicts and controls the HVAC systems, which can then result in a direct impact up to 40%. We already reached around 39% in one of our projects. So to give you a bit of an easier understanding graphically, how does it actually work? So we do have the building data, right? As just said, data points from sensors or actuators, and put this in a database. And then we combine also the weather forecasts and put this all together in one place. And this is then the kickoff phase for the artificial intelligence, where it is initialized and starts really to self-adapt to the building, right? It creates a digital twin and is then also capable of analyzing the thermodynamics of the building. And then in this first initial phase doesn't really take too long until first optimization commands will then be sent back via the building management system to really optimize specific set points, to optimize specific valves, for example, so that you really go away from a reactive approach to a very active predicting and controlling approach. So this is just a very simple example of how the software works. This is a case that we've gone through. So on the left side, you see that the current heating valve was fixed at a position at 75%, right? So this constant high opening of the valve consumes actually unnecessary energy. And what we are then doing on the right side, as you can see, is detecting on the one side the anomaly, and then the valve position was variably and dynamically adjusted so that the valve opening operates based on really actual demand. Of course, we also provide a dashboard, meaning so that everything that happens behind the curtains is no black box. So the user, which is often facility manager, really has a transparency in terms of real-time monitoring. It's also enabled to do analysis and benchmarking, and obviously, and of course, it's very important and easily then to detect an anomaly during the operation mode. And this data can then via an open API also being sent to other tools, for example, ESG tools. I guess you also might wonder, how do we actually quantify the impact? So how are we able, we generated savings? Well, we use an internationally recognized standard. This methodology is called the IPMVP option C methodology. And this incorporates actually a very holistic view. And we request historical energy and consumption data. We revise this data with the cooling and heating days so that it stays comparable. And then we kind of create a statistical model and forecast what would be the energy consumption for the next months based on the historical ideas. And so we are actually able to build up a baseline and then see in real time after the implementation of our software what is actually happening. So these are some of our reference cases. Our portfolio ranges from offices to retail store to clinics and school and many more. And of course, when we do a project, then we have the goal to reach similar results than we do in our current projects. So last but not least, how are you actually able to, what are the requirements to deploy our software, and how are you able to really generate such savings? So first of all, as said, like we are focusing on the commercial building sector, beginning with buildings of 5,000 square meters. Then a building management system needs to be in place. This is an absolute prerequisite. And then optimally and ideally, this is our sweet spot, is when those building management system communicate via BACnet IP, because then our solution is a plug and play solution and can directly start to analyze data and then also send demands back to the building management system. Thank you. That's it from my side. So if you do have any question, feel free to text them in our chat.
Thank you very much, Mark. I have a quick question before we move on. The numbers and savings that you have mentioned are really quite promising. But how long does it take for your average client to feel first tangible results when you implement your solution?
Yeah, a very good question. So actually, it happens quite fast. So of course, it differs from building to building. But speaking out of experience, it takes roughly 3 months, 2 to 3 months, until you see first results. And then over the course of the year, right? So this is actually why we want to have at least 1 year, right? Because then we have like winter season, we have covered every season, and then we can in the end really see, okay, what is the average, right? But like first tangible results can actually be seen after 2 to 3 months.
Okay, wow. And I'm sure everyone in the audience can contact you if they are interested in your solution.
Exactly, yeah. Thank you.
Our second startup pitch will come from the Italian startup NRW, and I would like to welcome Marco Martellacci, their chief scientist.
Thanks. Thanks to all. Share the screen. Okay. My name is Marco Martellacci. I'm the founder of NRW, one of the founder, and I'm innovation manager in NRW. I'd like to show you what we do and the many projects in AI that we are doing in these days. So NRW, sorry, just a second. NRW was born to achieve, to create efficiency in the buildings. We do this reduction consumption in the HVAC system, and we do this with a retrofit solution. We use IoT device, sensors, obviously a cloud solution. I cannot. Our services are energy consulting because we have a lot of engineers, energetic engineers, electrical engineers, and so we are. The first step is the consulting. After that, we have a solution for the monitoring, energy monitoring, environmental monitoring, and after that, we can prove HVAC optimization. The elements of the core solution are data logger in the meter, eSense that are wireless sensors with battery and are just configured, and so it's very simple to install it. We have obviously the algorithm in the cloud and our actuator. The actuator are the device IoT where you can install in the HVAC power system center. Obviously, we have also a web app to monitor everything and set up all the components. But as we said, the building sector is responsible for almost 40% of global CO2 emission, and the problem that we solve is a very complex problem because fragmentation of energy data hinders building management and strategic policy making. And the energy scenario is even more complex. Nowadays, we are talking about decentralization, decarbonization, digitalization. And there's no infrastructure to manage the many-to-many energy grid. But we can also add other problem. For example, the comfort versus saving versus demand side flexibility, and how to quickly and easily manage the entire building portfolio. And Brian, we developed a new solution. The name is Spike, Sustainable Plug and Play IoT Kit for Energy. And this solution, we use AI to solve some problem that I'll tell you. This is the main schema. We can get the data from photovoltaic panel, power system, but also from the school or all type of buildings. And we can handle also the immobility. So it's important to create a solution that has an optimal control and orchestration of energy production, consumption, storage. Obviously, the comfort is important, but the flexibility is a very important point that nowadays we are talking always more. The key innovative in future are the full plug and play retrofit solution, a combination of proprietary hardware and software, and leveraging AI to unlock a predictive control. Sorry. How it works? We build a mathematical model of the buildings, thanks to our sensor and actuators. After that, we are sorry, but basically on this model, we can provide optimal strategy to optimize the energy behavior of the building. For implement optimal strategy, we use the AI. There are two main technology, the reinforcement learning, or model predictive control. We use both of them. The important things is to create a controller that is on trade-off between indoor comfort, energy saving, CO2 emission, flexibility, and energy cost, for example. So the process is that with the information, with the historical data, we can create a mathematical model of the building. After that, we can simulate the building behavior, maybe also on entire season of the building. We can define the optimal strategy with the user, with the client. And so we are ready to start with the actuation of this with this strategy, sending commands to the actuators. Just an example, if I have an app where I have a simple slider and I can decide the comfort and the consumption. Sorry. we can decide to leave decrease the internal temperature to benefit in saving, and it's very simple. And all the solution can optimize the regulation to maximize the comfort that you can have. It's important to also use the artificial intelligence to define the CO2 reduction. We do this with data capturing. Obviously, we're using an energy model and define the consumption, the efficiency that we created, and we translate this in CO2 reduction in base of the production that we use. We are participating in 3 main projects in the EU projects: Smart Building, Smart to Be, sorry. Smart to Be is a project where it's important to create a smartization of the building, to have the possibility to regulate the building with the flexibility, energy cost, and so on. Reflex is where we wanted to create a platform for demand side flexibility. Energate to create energy efficiency marketplace, bringing together energy services and the sustainability finance to accelerate the transition to the green. We have done some POC in Copenhagen, in Amsterdam, with other projects, and the results are very optimal. And at the end, with this new solution that now is in testing, we can optimize a correct trade-off between energy consumption and comfort, digitalize building management to have an intelligent use of the resource, unlock the digitalization of energy district for the future energy communities. This is a very good point, and reduce the environmental impact of the buildings. Thank you. Thank you.
Thank you very much, Marco. Last but not least, I would like to hand back to Silvana, who will present an open call and other opportunities for European SMEs.
Thank you very much, Enrique. So, yes, this is just a quick wrap up about open calls and other opportunities that are linked to the subjects that we heard today. So, artificial intelligence and energy efficiency and so on. This is really quickly one call that is going to be open around May. We don't have still the fixed date, but it should be May. Is going to be actually one call, but that let's say contains 4 different kind of activities that can be funded. They're going to be lump sum, so it's going to be like a financial support for SMEs from all over Europe working on artificial intelligence and blockchain or blockchain applied to different fields such as energy efficiency. Then we have manufacturing, mobility, and logistics. So as you see here, we're going to have support for internationalization, which means participation to events or to a mission that is going to be organized by the project. Then services, so they can be consultancy services, tech transfer, analysis, development of proof of concepts, and so on. Training sessions for to participate in training, coaching, mentoring. Then test pilots and demonstrator projects. So projects that should involve at least 2 companies, one from the AI or blockchain sector and one from one of the sectors I mentioned before. And the idea is to support the adoption of technologies to enhance, as we have learned today, a specific part of a product or a service of a company. We're going to share the slides later, so just for you to know, there's another initiative which is called Restart SMEs. is actually to create a matching and matchmaking between companies from the manufacturing sector that are interested in adopting technologies, so in being more digital. With this initiative, there's also like a support for the companies from the manufacturing sector in developing a roadmap of getting to know how the challenges can be tackled by technology. And last but not least, then the Enterprise Europe Network, which is, if you know already, there are different nodes in different regions. We work at regional level, supporting SMEs in partners research regarding business, research and development and technology, and open call support and any kind of other topic that you may be interested in. So just in case you need, these are my contacts. Well, I'm one of the organizers of this event together with Ulrike. So thank you very much for having participated. And Ulrike, the screen is yours.
I don't have any slides to share actually. I would just like to close the session and thank you all. Thank you, the speakers, and of course our partners and the audience for your interest in AI. I would like to invite you to get in touch with us if you would like to learn more about the topic, or if you're in North Rhine-Westphalia, please do contact us if you want to identify use cases for your own company or need other help in getting started with your AI journey. I would like to thank you again, Silvana, and the rest of your team at Piemonte Innova for the great cooperation in organizing this webinar. And I hope you will join us all soon. Goodbye and have a nice day.
Thank you.
Thank you. Goodbye.
Thank you.
Goodbye.
Goodbye.
Bye-bye.